Here to help you with Chapter 4, Lesson 7, one-step equations, you guessed it, with positive and negative integers. So we're going to take everything that we've been learning, folks, when it comes to computing integers, positives and negatives, move into one-step equations. Now today we're going to focus on addition and subtraction, eventually get to multiplication and division, and yes, eventually we get to two-step and three-step and more multi-step equations. For now, go ahead and whatever the date is, whatever the assignment number is, go ahead and title your paper. Come on back when you're ready. So here's a little example. X plus 5 equals 11. Actually, you've seen something like this before. I want you to look at the model, and I really want us to focus on positives and negatives today. So if our goal is to get x by itself, let me put a little disappearing ink here. We want to get rid of the 5. So how would we get rid of 5 positives other than just saying to take away? Well, just like take away, you could say the same as by adding 5 negatives, as long as you're fair to both sides. How would we write that with numbers and symbols? Well, here's the new part for today. So to get rid of 5 positives, we're going to now add 5 negatives. And of course, be fair to both sides. Why does that work? Because 5 positives and 5 negatives cancel out by making 0. No need to write a 0. You can just bring your x on down. Meanwhile, if you had 11 and you took 5 away, because 5 positives and 5 negatives, 5 0 pairs cancel out, that would leave you with 6. And of course, to check, you can take your original equation, but now we don't think x is an unknown, we think x is known. Substitute in and check it. So ladies and gents, that is where we're heading for today. But no more subtractions, no more just whole numbers. We're really going to focus on positives and negatives. All right, a couple more examples before we get into some that you might choose to write down. First, we're going to be asked to write an equation given the model. So on this side, I see an x, I see 3, and those 3 are positives. And over here, I see 1, 2, 3, 4, 5, 6, and 7. Now, how are we going to get rid of those 3 positives? By putting 3 more negatives on there. Of course, that's not fair to do to one side, so let's do it to both sides. 3 negatives on the left, 3 negatives on the right. How would we write that with numbers and symbols? Well, by adding 3 negatives on the left and adding 3 negatives on the right. Why does that work so well? Because 3 positives, 3 negatives cancel out. I'm going to go ahead and cross those out. And of course, if you had 7 positives and you have 3 0 pairs, that leaves 4 left over. Does it work? Take your original equation, substitute in 4, and of course, 7 equals 7 is a true statement. All right, let me do one more before we pause and really think about questions. But as we're doing this next one, think about how they're similar, think about how they're different. All right, take a look at the model. First of all, on the left side, I'm seeing only 8 positive blocks. Meanwhile, on the right side, I'm seeing a mystery and then another 6 blocks. All right, now that we have the equation, we are hoping to solve this equation. First of all, as you can imagine, we'll want to get rid of those 6 positives with 6 negatives, but that's not fair. Anything we do to one side, we must be fair to the other. So let's go ahead and clone these fellas and pop them over there. How do we write that with numbers and symbols? Well, we added -6 on both sides. So let's go ahead and write that with numbers and symbols. Adding -6 on the left and adding -6 on the right. The reason for doing that, of course, is that 6 positives and 6 negatives, those make 0 pairs, those cancel out. I'm going to cross that off down below as well. Meanwhile, if you had 8 positives and you have 6 0 pairs to get rid of, that of course would leave you with 2. But we're going to check it. We're going to take our original equation, we're going to substitute in the 2. And in this case, that appears to be a true statement. 8 is equal to 8. So as you're writing some of this down, maybe you're drawing the models for it as well. Look at how those problems are similar. Look at how they're different. In this case, they're both positive 3s. How do you get rid of positives with negatives? The left problem, we added -3 to both sides. The right problem, we added -6 to both sides. Zero pairs cancel out. And of course, we have for each of these, problem, work, our solution is circled, and we have checked it. All right, let's make it a little more complicated now, shall we? Pause the video, go back if you need. I got 2 more examples, and then we're going to do 4 more together, actually. The first thing I'm going to do, however, when I see subtract 9, I want you to understand, what does that subtract mean? Well, subtracting 9 really means adding the opposite of it. So how do you get rid of 9 negatives? Well, if you want to make 0 pairs, the opposite of 9 negatives would be 9 positives. And if you're going to add 9 to one side, you better be fair and add 9 to the other side. In this case, -9 and +9 make 0. Good. That leaves us only with the x, and that's what we wanted to know. -2 plus 9, some of your number line folks, go down 2, go up 9. And in this case, x is 7. Or is it? What we're going to do now that we think we know what x is we're going to substitute it back into the equation and check our work. Now, oftentimes I even put a question mark above here, and I have suggested to many of you, cover up that other side. Don't cheat yourself. I'm going to change subtraction to add the opposite, and if you go up 7 and down 9, you're going to be below water at a lowly -2. And that's a true statement. 7 subtracting 9 is in fact the same as -2. Let's take a look at the second example, and I want you to look immediately at that left side. What do we have here? Subtracting a negative. We're going to change subtraction to add the opposite. That makes a little more sense. So I see subtraction of a negative as adding a +5. And how do we get rid of 5 positives? With 5 negatives. Let's add 5 negatives to one side. Let's add 5 negatives to the other side. Naturally, 5 positives, 5 negatives cancel out. And if you have 22 positive symbols and you subtract 5, you're still going to have positives, but only 17 in this case. Now we think that's our solution, but let's go ahead and check it. Taking the original equation, but now instead of writing x, we think we know what x is. We think x is 17. So we substitute 17, put a little question mark here, take our finger, take our hand, and cover that up. Now I myself will change subtraction to adding the opposite. And so we end up with 17 and a +5 makes 22, which is a true statement. So again, look at all those problems are similar. Look at how they're different. They're similar in that both are subtraction. Here we have subtracting 9. Here we have subtracting -5. But they're different. Notice that when I change it to add a -9. I change it to add a +5. On the left side, how do we get rid of 9 negatives with 9 positives? On the right side, how do we get rid of 5 positives with 5 negatives? But they do have in common that you must be fair to both sides. Anything you do to one side, you do to the other. And of course, don't forget the problem, your work, your solution, and your check. All right, here we go. Your objective always is to isolate the variable. Get that variable alone and by itself. Now, to undo addition, I don't want you to try subtracting anymore, although I don't have a problem if you subtract. But anytime you subtract, remember, you're going to change it into adding the opposite. So I'm always going to change my addition by adding the opposite. Undo my addition. Rewrite it as an addition problem. All right, 4 more examples, folks, and then we start up our homework. If you want, pause, write these down, and then come back and check your answers in a sec. So in this first problem, we have n, and then we have 3 negatives. I like to put parentheses there, but you don't have to. So how do we get rid of 3 negatives? Well, of course, we add 3 positives, and we must be fair to both sides. Now, in this case, 3 negatives, 3 positives cancel out, leaving me with n by itself. Good. -7, +3. I have 0 pairs to take away. We're still in the negatives, but not as far. To check it, I'm going to go ahead and recopy the original equation, But now we don't think n is unknown, we think n is known. We think n is -4. So I'm going to put a little question mark over here. And I'm also going to go ahead and take my imaginary finger, pencil, cover it up. -4, -3, no zero pairs, put them together, and that appears to be a true statement. So our final answer, n must be -4. Let's head to example 2 right next door. We have x, we have 12 positives. How do we get rid of 12 positives? By adding 12 negatives. And of course, I'm going to be fair to both sides there. I know. Some of you want to go straight into subtract. If you do that, that's fine, but be careful when you get -3 minus 12 that you know your integer rules. All right, onward, Mr. Callan. 12 positives, 12 negatives cancel out, leaving us with x by itself. Meanwhile, I see 3 negatives, 12 negatives. In other words, we owe money, and then we owe more money. Or do we? Let's go ahead and take the original equation, x an additional 12. And now we think we know what x is. Substituting in -15, and let's see if it works. Cover up that side, -15, 15 minuses, 12 positives. I see 0 pairs to take away. They're going to be negatives left over, and in this case, only 3 left over. And how about that? Looks like a true statement to me. All right, so we got a blue example 1, we got a green example 2. Let's go ahead to example 3. I'm going to do this one in black. Now again, I see y subtracting 5, but I'm going to change my subtract to add the opposite. Now how do we get rid of 5 negatives with 5 positives? Naturally, 5 negatives, 5 positives cancel out, leaving us with y is equal to -11, or is it? No fake checking. Copy the original equations. Substitute in what we think is there. Cover up the other side so your brain doesn't cheat yourself. And again, I'm going to change this subtraction into adding the opposite. But if I have -11, -5, I'm thinking -16. Boom. This is a true statement. All right, let's get a little purple out, shall we? Or, oh no, there goes my pencil. How about orange? Why not? All right, so in example 4, I see f subtract negative. Whoa, subtract negative. Forget that. What does subtracting a negative mean? I'm going to change that to add the opposite. Oh, disappearing ink. That's not very helpful, Mr. Callan. Let's try that again. All right, so f subtracting -5 equals 13. We're going to change this to add the opposite. There we go. So really what we have is 5 positives. How do we get rid of 5 positives? With 5 negatives, of course. And I'm going to add -5 to both sides just to keep my equation fair and balanced. Why does that work? Because 5 positives, 5 negatives cancel out, which leaves us with f on one side and +8 on the other. But in order to check, I'm going to recopy the original equation. We think we know what f is, so I'm going to write 8 with a little question mark. And, not surprisingly perhaps, I'm going to change subtraction into adding the opposite. So in this case, I know I have 8, but if I take away a det, if I take away a div, it really increases. And in this case, 13 is 13. Look at all those problems. What do they have in common? Problem, work, solution, checking. Get rid of positives with negatives, get rid of negatives with positives. How are they different? They have different variables, they have different numbers. Interestingly enough, example 2 and example 4, we get rid of positives with adding negatives. Add -12 to both sides, add -5. In example 1 and example 3, we get rid of negatives by adding positives. All right, so as you go through this, you can ask yourself, okay, what homework problem am I working on? Is it more like example 1 or example 2 or example 3 or example 4? That's what I got for you today, folks. Take care, do well, and let's grow.